Hello and welcome to Technical Kranti. And today we'll be looking into the fifth question on recursion, which is palindrome partitioning. But first, let's have a look at the thought for the day and let's move on to these other questions and videos that we have released in the recursion. And let's look at the question. So, you have a string and you need to partition the string such that every partition is a palindrome and you need to find all such partitions. For example, if BAAB is the string given to you, then one partition could be this, where every string is palindrome. Then another partition could be this, where every string is palindrome, and then this could be palindrome. So, firstly, what is palindrome? Let's have a look. So, if a particular string, when read from left or right, is the same, then it is called palindrome. For example, here it is BAAB, and from here also it is BAAB. So this is palindrome. How are we going to do it? So, so we will deploy recursion. So to begin with, we don't have any partition, and we start with zero index, right? So for the first recursion, the value of index is 0 and I will range from index to the length of string, which is 3, right? So what will happen is we will see that from index to I is this part of the complete string is a palindrome. So for I equal to 0 and index fixed to 0 is 0 comma 0 of string is a palindrome. So one single character will always be a palindrome. Yes. So what happens is we find one part of the string which is palindrome. So we need to see that after this part, so after this part is signified by I plus 1, which is 1, can we further partition this string into a palindrome partitions? So what will happen is the value of index for the next recursion becomes 1 and I ranges from 1 to 3. So again we'll see that index comma I of the string could be a palindrome. So 1 comma 1, which is A. So yes, so B and A. And the next index from where we have to do palindrome partitioning is 2. So index value is 2. I ranges from 2 to 3, right? So what we see is index value is 2 and I is also 2. So 2 is this, and we find another palindrome part of the string, which is A, and the next index to be seen is 3. And similarly, we get B, A, A, B as one one partition where each part is palindrome, right? All right. So then we hop back and yeah. So over here, when index was 2 and then like with this recursion happened, like for index equal to 3, recursion was this. Then we come over here and over here index ranged from 2 to 3, right? So for I equal to 2, we found that okay, this is one part which was palindrome, and for I equal to 3, index comma I would now be 2 to 3, which means it would be a part of length 2, which is AB. So is AB palindrome? No, AB is not palindrome. So there is no more addition, and we go over here. For I equal to 1, we had already added this part. Then for I equal to 2, that A comma A, 1 to 2. So when I equal to 2 and index equal to 1, the string from index to I would be index 1 to 2, which is AA. Is AA palindrome? Yes, AA is palindrome. So we get this particular partition, right? And the next index to be considered is 3. And we see that 3 is the last index, which gives me the part B, and B is palindrome. So F of B, AA, and B. This is another partition where every part is palindrome. All right. Okay. Then we come over here, and I becomes 1 now, because for 0 we have already gone over here, and then I becomes 1 here. So is B a palindrome? No. Then I becomes 2 and we get BAA. Is BAA palindrome? No. Then I becomes 3 and BAAB is palindrome? Yes. So BAAB, this becomes another partition where where this part is palindrome, right? So just one part is there in this partition. So I hope you understood how we are finding the palindrome partitions. If not, let's have a look at the code where you'll have a different perspective to the same approach. So what we are doing, we are calling this particular function where we are doing recursion. So this is the base case, and we'll see this later. But let's look at the recursive case. So what we are doing, we are running a for loop from index to the length of the string, right? The same thing that I was showing over here. The value of index, which is this, and this, will keep on changing based on this particular instruction, right? So I plus 1 becomes index in the next recursion call. But when do we come over here? We come only when, starting from index to certain value of I, we find that that particular part of the string is palindrome. So when we have found the first palindromic partition of the string, only then from the next value of I onwards, we'll say find further partitions. All right. And at the base condition, if the value of index is n, then we'll just append the complete partition. Let's see how we are finding if the particular part of the string is subset or not. It is simple. We'll just calculate the length of the string and left and right values. So until left is less than right, we'll just say if the left is equal to right, then it's good. If left is not equal to right, then just return false. And after each iteration, we are incrementing the left pointer and decrementing the right pointer, right? So I hope you understood this complete code. Let's submit and see if it is getting submitted. So yes, it is getting submitted. I hope you understood the question, the approach, and the solution. If you did, please give it a thumbs up and subscribe to my channel. Thank you. Bye bye.